So here in this problem, we are given the value of a and b. So a is given by sum of sine alpha plus sine beta, and b is cosine alpha plus cosine beta. Now we need to show that tangent of alpha minus beta over 2 is given by this particular expression. Let us begin. Now what we're going to do here, we're going to use a formula to solve this problem. We know that whenever we have tangent squared theta, so that's given by 1 minus cosine of 2 theta divided by 1 plus cosine of 2 theta. In our case, if we suppose that theta is given by alpha minus beta over 2, then we'll have tangent squared. In place of theta, we will replace with it alpha minus beta over 2. So this will be equals to 1 minus cosine of alpha minus beta divided by 1 plus cosine of alpha minus beta. So what we'll do, our goal will be to determine the value of cosine of alpha minus beta first. Once we have that value, which will come in terms of a and b, then we can replace this value in this particular equation. Let's call it number 1, and then we should be able to solve our problem. Okay, now how shall we find out the value of cosine alpha minus beta? To do that, all we have to do is take the value of a, square it, and then add it to b squared. And I'll leave the algebra for you to try out. So this is going to give us 2 plus 2 times cosine of alpha minus beta. Now, when we isolate cosine of alpha minus beta, that should give us a squared plus b squared minus 2 whole divided by 2. So we're going to use this particular formula and replace in place of 1, in place of cosine alpha minus beta in 1. So we have 1 minus a squared plus b squared minus 2 divided by 2, and in the denominator we have 1 added to a squared plus b squared minus 2 whole divided by 2. Now let's multiply both numerator and the denominator with 2. So that will give us, we have 2 minus a squared minus b squared added to 2 divided by, we have 2 plus a squared plus b squared minus 2. So here we can cancel out 2 and 2 from the numerator, from the denominator, and in the numerator we'll be left with 4. Let's take negative as the common factor, so that gets multiplied to a squared plus b squared divided by a squared plus b squared, and this is the value of tangent squared alpha minus beta over 2. So what we'll do, we'll take the square root on both sides such that we get tangent of alpha minus beta over 2, and this will become equals to the square root, or here we'll take the positive and the negative value, so plus or minus the square root of 4 minus a squared plus b squared divided by a squared plus b squared. So we've successfully proved the problem.